Now we'll try and realize a voltage controlled current source using a MOS transistor. Now this may be a little confusing because the MOS transistor by itself is a voltage controlled current source. Now a MOS transistor has this small signal incremental equivalent VGS and GM-VGS. Obviously this is a voltage controlled current source. As you know, many parameters of a semiconductor device are strongly dependent on temperature, and this GM also changes with temperature. Okay. Now what we would like is to have a voltage controlled current source which doesn't do this, which doesn't have such a strong dependence on temperature and so on. Okay. So like the voltage controlled voltage source, we would like to realize that using negative feedback so that it doesn't depend so much on the MOS transistor parameters. It depends on some other components which can be more stably realized. Okay. Now a voltage controlled current source follows the relationship I out equals V in times some G1. This is usually denoted by GM, but to not confuse between GM of the MOS transistor and this GM, I will use a different term for this transconductance. This is G1, or I could write it as V in divided by R1. Okay, R1 is just the reciprocal of G1. Now, what does this mean? We have to realize this using negative feedback and using a MOS transistor. In a MOS transistor, we have the controlling quantity VGS and the controlled quantity which is the drain current, and that is equal to GM times VGS, and ID flows from drain to source terminal. Okay. So the output current has to come out from either the drain or the source terminal, whichever is convenient. Okay. And the error between the actual and desired values has to be applied to the gate source voltage. Okay, because that's what eventually controls the current in the MOS transistor. So we want I naught equals V in by R1. Another way to write it is we want V in minus I naught R1 to be 0. Okay. Now this you can think of as the error, right? V in minus I naught R1 as the error, some sort of error between desired and actual values, and that should be 0 eventually. Okay. So this means that the error voltage V in minus I naught R1 or the negative of that should be VGS. So VGS should be either V in minus I naught R1 or I naught R1 minus V in. Of course, it can be some other quantity which is still proportional to this one. Okay. And what is the negative feedback action that we want? If I naught is large, it tends to increase, then VGS must fall. Okay, if I naught is too large, larger than desired, VGS must fall so that the current reduces. Okay. And similarly, if I naught is too small, then VGS must increase so that current increases. Okay. Eventually, the drain current of the MOS transistor will be the output current I naught. Okay. So clearly you see that the first form is compatible with this. I naught here appears with a negative sign. So if I naught is too small, VGS will be a larger positive quantity which tends to increase the drain current. Okay. So VGS has to be equal to V in minus I naught R1. The other way around doesn't work, because if then I naught is very large, then VGS actually will become larger. Okay. So negative feedback action is obtained by having VGS to be equal to V in minus I naught R1. Okay. So if VGS equals V in minus I naught R1, then we basically have this action. Okay. Now let's try to make a circuit that accomplishes this. This is VGS and this is GMVGS, or basically the incremental drain current ID. Okay. Whenever we have a current output, right, we need a terminal at which we take the current, and if we want to monitor the current, we have to use the other terminal through which the current is flowing. What I mean is, let's say we have a voltage. Okay, this node provides the voltage, and if we want to measure the voltage, we just take this node and connect it to something else as well. Okay, then we can sense this voltage. To sense a current, we have to place something in series, and one possible way to do that is, in this case, for instance, the control source is like this and the current is flowing that way. Okay, we can take the current output from one of these terminals, from that one. Okay, and the same current is flowing through this, so we can use the current flowing here to make a measurement of the current. Okay. So let's try and do that. What is the measure that we want? We want Vin minus I naught R to be 0. Okay. So I naught has to be multiplied with some R so that it can be compared with a voltage. Now obviously the drain current is the output current. That's where we get a current output in the MOS transistor. Let's say that this I naught, it is flowing that way downwards. So if I pass it through a resistor R, the voltage here will be I naught times R. Okay, and this one, let's say I connect it to ground. Now the voltage at the source node of the MOS transistor is I naught R. And what did we want the VGS to be? We wanted it to be Vin minus I naught R. So it's very clear that if I connect the gate to the input voltage, I will get VGS to be Vin minus I naught R. Okay, and the load can be connected to the drain, because the same current that is being sensed here, that is being passed through this resistor, flows through the control source and into the load. Okay. For now I will represent the load as a resistor. Is this fine? So what I have now is an arrangement where I connect a resistance between the source terminal and ground. That means that whatever drain current is flowing will flow through this resistor and create a source voltage of I naught times R. If I connect the gate to the input voltage Vin, then the gate source voltage will be Vin minus I naught R, which is exactly what I wanted. And now you can see what happens. If I naught is very large, then this VGS tends to be smaller and the current tends to reduce. Okay, that's the negative feedback action that we want. So the circuit that we want for the voltage controlled current source is basically this: the input applied to the gate, a resistance R between source and ground, and the load connected between the drain and ground. That is, the drain current is made to flow through the load. For now I'll assume that it's a resistance that I can connect in that fashion. Okay, so this is our voltage controlled current source, or the incremental small signal picture of a voltage controlled current source. Okay.